My name is Rami Alshafi. I'll be your mentor today throughout the hackathon. If you need help, shout my name, raise your hand, or get my attention somehow. I'm here to introduce you to the hardware components that you have and what could be available to you throughout the hackathon and what the process of getting those hardware equipment. So every one of you should receive an individual kit. Everything in this kit is for you to keep. You can take it with you. It's our way to thank you for your time. In this kit, you'll have a Raspberry Pi 3, and it should have an SD card already inserted in it, and it's pre-configured with the right operating systems, and we have already pre-installed all of the developer tools that you need there. You should also have the automation FAT, which is the daughter board that goes on top of the Raspberry Pi. And it has a relay, and this relay supports up to 24 volts. And there are syncing outputs, also can handle up to 24 volts, and they connect to ground. So let's say you hook up an LED, the ground LED of the LED should be connected to the output, and the output pin is going to be connected to ground or not. It's not going to supply voltage through it. And then we have inputs. We have digital and analog inputs. The digital inputs are buffering inputs, so also they can handle up to 24 volts. And you should get a power supply, and the power supply should provide you with enough current for additional components that you would be attaching on top of the Raspberry Pi. And you should have an Ethernet cable that you can connect it to the Raspberry Pi and then to the router or to your PC, and this is going to be how you're going to be communicating with the Raspberry Pi. You could eventually configure it to connect to the Wi-Fi near on your table, so you no longer need it. It's really up to you. But you're going to be working with the Raspberry Pi in a headless model. Okay. You should also have a 32 gigabyte thumb drive, and it will include the golden image that we used to pre-configure the SD cards. So if you ruin your Raspberry Pi software-wise, you're okay. And if you ruined it hardware-wise, we'll figure something out. Okay. But yeah, feel courageous to ruin everything. It's okay. You can restore the full operating system. In this thumb drive, you should be able to also have a bunch of tools that we use to configure the SD cards for multiple operating systems, Windows and Mac and Linux. And what else? I think I also have an updated version of this thumb drive. I might walk around and give you a copy of which is going to include all of the presentations, even though they're available online, but for convenience. Also, we have the example codes that you can use already in this thumb drive, and also you're going to be getting the OCF device spy. We call it device spy, which is basically a device that can simulate the client that you can use to manually generate GET request and POST request and do the onboarding. Just kind of like you could do every step individually. Also, you should have the onboarding tool and generic client in this thumb drive. Okay. So everything I've said so far, you can keep with you. Everything I'm going to say next is we want to reuse in future hackathons. So we have a general kind of kit, and it's kind of a pool of electronic components and whatnot, so I'm kind of briefly going to talk about each one. So we have a magnetic contact switch, which is can be used to detect if a door is open or a window is open or closed, so you can sense kind of, or a cabinet or anything of that sort. We have also a pack of environment sensors in this EnviroFat, which includes an accelerometer and a light and color sensor, and a temperature sensor, and a humidity sensor, and pressure sensor, and altitude sensor as well. If you want the accelerometer alone, we have also a bunch of accelerometers. This is a triple axis accelerometers. We also have a force sensor, so when you press on it, the more force you give it, it changes its resistance, and so you can map the difference in resistance to the amount of force it is sensing. So it'd be great for, like, you can put it theoretically in the shoe. You can measure the force of you stepping or whatever. We have a stretch sensor, also resistive. It's basically a conductive rubber, and if you stretch it, it becomes less conductive and more resistive, and again, you can map that difference in resistance to the amount of stretchiness. We have a capacitive touch sensor also. I think has maybe 12 leads. You can connect this to anything conductive or anything that has a lot of water, like a human, animal, fruit, anything. And it could be a button. So you could touch your partner, and your partner becomes a button to do something you want, right? You can connect fruits. I don't know, we might have fruits. Flex sensor, also resistive. So the more it flexes, the resistance changes. So you can map the resistance difference to the amount of flex it's sensing. We have a liquid level sensor. This is like what do you have in your car, gas tank. And we have a liquid flow meter. It has a wheel inside of it, and this wheel has a magnet, and then it has a Hall effect sensor that senses that magnet passing by, and then you can count the revolution per minute of this wheel, so you can, and then you can kind of calibrate every revolution equals this many liters of liquid or whatever, or ounces. More sensors. We have an infrared sensor. We have a light and color and proximity sensor. Also, it can sense gesture. So if you move your hand above it from right to left, it will know that you are going in this direction. So you can like have, I don't know. We have a photocell. Also, it's a resistor that changes its resistance based on the light it receives. And we have a Hall effect sensor, which is a sensor that senses a magnetic field. And we have a simple analog temperature sensor. We have a motion detection sensor, and also a soil moisture sensor. So if you have a plant, you put that moisture in, and it tells you how moist the soil is, so you can water only as needed. So if there is rain, you don't have to water anything. It doesn't have to be on a schedule. It's gonna water the plant as needed. Ultrasonic sensor that can measure distance. The shortest distance is at 3 centimeters, and then it goes, I think, 2 meters. It could reach 3 meters. It's at a 45 peripheral angle, I guess. We have a light transistor. If it receives light, it connects. So it's pretty much a switch that you can switch on and off by light. And we have a pulse sensor, which kind of senses your heart rate. You can put it on your earlobe or your finger or on your chest, and it can detect your heart rate. We have a vibration sensor. anytime, and this is a kind of a sensitive one. So if you put it on an object and that object vibrated in any way, shape, or form, you can detect that. We also have another temperature sensor that's kind of sealed if you want to put it inside water or something like that. We have a lot of LEDs. I pretty much got every possible color I can get. So the top row has kind of individual colors. The bottom row, the RGB, it's an LED that can change it. It can be green, red, and blue, and you can mix and match. And I believe this is a common anode, so the long lead should be connected to ground. We have an IR LED, so you can actually generate an infrared. So you can map that with an infrared sensor if you want to play with the IR stuff. And we have an ultraviolet LED. And we have a lot of motors too. We have a servo motors that's kind of angle-based, 0 to 180. And we have a mini vibrating sensor and a simple DC toy sensor. And we have a bunch of drivers for this. So if you want to supply more current for these motors, and actually it's a good idea to separate these motors from the same power supply as your Raspberry Pi, because sometimes motors have a back electromagnetic field that could interfere with your Raspberry Pi and could reset your Raspberry Pi. So yeah, have the power supply for the motors separate. And these drivers give you the option to connect a different power supply. And we have a bunch of kind of inputs like potentiometers that you can use as knobs, and buttons and switches, and remote controls, and 2-axis joystick. We have also screens. We have an LCD screen that's colorful. We have an ink screen. We have an OLED screen. We also have analog meters if you want to measure something, some signal. And we have a bunch of other stuff, resistors, and the one in the upper left corner is actually pretty cool. It's called the thermoelectric module. What it does, it maps differential temperature differential to voltage differential. So if you give it voltage, it gives you both heat and cold. And this is what you get from like a thermoelectric refrigerator, if you have one. Also, it does the opposite. If you give it heat and cold, you can harness electricity. And maybe you've seen some products that, like a cook pot that has this. And you put water in the pot, and when you cook something, and the fire is hot and the water is cold, and then you can actually harness energy out of these modules. So they're pretty cool. We have alligator clips to connect things easier. We have a bunch of relays, and these relays are much beefier than what you have on your automation fab. They can handle, I think it's written on it, but I think it's at 240 volts, AC or DC. The one at the bottom, it's a heating pad. You give it power, it heats up, and the more voltage you give it and current, it's going to heat up. And it's a gentle heat. The most important thing I want to point out is the bottom right is a micro USB breakout. So you can connect the same power supply of the Raspberry Pi and use that to power your motors, for example. We have also magnets and extra breadboards. On top of this, we also have a team kit. So every team will have an additional kit that it can use, which has more LEDs and resistors and breadboards and a screwdriver for your terminal blocks. Also, we have a bunch of construction material like wood and cardboard and poster boards, tapes, glues, box cutters, scissors, whatever, just a bunch of stuff that you can take. And of course, the construction material, you don't have to return it because you probably cut it and do all kind of things with it. But yeah, hopefully you would enjoy this hackathon.